Welcome to this tutorial on boost converter simulation using PSIM software. In the previous video, we have seen the basic theory of what is a boost converter. A boost converter is used to boost a fixed voltage to a variable voltage. So we have seen the switched mode power converter, which is named as the boost converter, using the basic components and the theory. We have also covered the design of the boost converter. In this tutorial, we will see about the simulation of a boost converter using PSIM software. So I will start from the beginning. So I will start first the PSIM software. So this is the welcome screen of a PSIM software. Let me close it. First I'll create a new file. Before getting into this file, we will see the overview of what PSIM is. So we'll have different file options here. Below that there is a ribbon which gives the basic operations like storing, saving and running the simulation and viewing the output. At the bottom we have a ribbon where I have the shortcut for different elements that I will use in this simulation. So if you hover over this specific button, it will show you the component. So we have the resistor, inductor, capacitor, followed by diode, thyristor, all the switching components. Then we have bridges, all these things, right? So what we are going to see is the simulation of a basic boost converter, right? So we are trying to boost a fixed voltage to a variable voltage or to some voltage higher than the input voltage. So first I need a source. So I'm going to use a source. Then I need an inductor. I hope you remember the basic structure of a boost converter. Then I need a controlled switch. I have different options here. I have a thyristor, I have a MOSFET and also an IGBT. I'm going to use a MOSFET. So let me take that here. At the other end we need a diode connecting through the load. So I'm taking here it as a resistive load. So I have collected the major components into this circuit arena. Now I'm going to connect all the components using the wire. So here I have a button called wire. So I just click it and now you can see the pointer has changed into a wire. So I start from the source button, go along the at the other end, then I leave it. This will be connected. So I connect all these components, get these, bring the load to the circuit. Now our circuit is ready. Is it ready to be simulated? Not yet. Before we get to simulate, we need to initialize the values for each and every block here. First I take the source. So it has a name and an amplitude. It is at 100 volt. I keep it as it is. Then coming back to the inductor, double click on it, inductor. Now you can find that the default value of inductance in PSIM software is 0. Let me put at some value. Let's say it is 200 micro. For micro you can directly use the value U, right? I would like to display the name of it, so I just click on it. So when I close it, the name of the inductor is now visible. The same thing goes for other things also. Here I have the diode, then the load has a default value. Let it be. I don't want to change it, right? I just want to display the name. Yes, I just click on this. For source also I wish to display the name. It goes on like this, right? Now there is a switch which is the MOSFET switch here. Now this switch has a control terminal which is the gate. So this has to be turned on and off at regular instants to achieve the boosting of the input voltage. So what can we do for that? In normal cases what we use is the generation of PWM, but PSIM software has a simple block which emulates a PWM. So this one is the block which is named as the gating block. So I'm going to use that block. So I'm going to directly connect it. Now let's get into this gating block. So it has a name, a frequency and number of points. As you can see, this switch requires nothing but a square wave pulse which turns on and turn off at specific time instants. So let's say I'm taking a single cycle starting from 0 to 360. If I want the pulse to be on once and off once in a specific switching cycle, it means that I need two switching points, one for on and another for off. Then what are those switching points? Here we are specifying it in the form of degree. Assuming one full cycle is a 360 degree, it starts at 0, and which means that the square pulse, it goes from 0 to 1 at 0 and 1 to 0 at 180. So what we are exactly looking at here is a square pulse which has a duty cycle of 50%, right? Let that be default, right? I also need a common ground, so I will just put it in here. Let us see whether we can simulate this circuit. So now I click on escape. Now the arrow turns to the original format. I just go and before running the simulation, I wish to save it. I just go to save. I wish to save it in some name. Let's say it is a boost converter. Let's say this is some one. I just save it in the desktop. Save. Now it is saved. Now I wish to run it. Let's see whether this thing can run. One more time. Running simulation engine. Simulation looks to be complete, but I need to see the visual output of how it looks like. So for that I need some form of voltmeters and ammeters. So what I'm going to do is I'm going to use an ammeter, voltmeter. We have two voltmeters here. One is voltage probe node to ground, and another one is a voltage probe. So here I'm taking it, I'm placing it at the source, and another one at the load. Let me just rename it. So V1 is the source. Let's say that is the input. Let's just display it. Then this one is the load output. Let's say this is V out. Now I'm going to simulate it. Now the simulation runs. At the end of the simulation, the sim view opens. So this is the window in which where you see the actual output of a PSIM. Here I have two variables, one is V in, another one is V out. I want to see these two things in separate windows. So first I click on this, click on add, okay, the input waveform is shown. Then I wish to add the output also. I just click on here, click on output, add, click OK, it is fine. So the simulation, as you can see, it starts from 0 and ends at 0.01. I want the simulation to run for a longer time. What can I do? I go back to the main simulation window, go to simulate options, go to simulation option, click on simulation control. You will have a separate clock based icon. Drag that into the main circuit and then click on. It will show you a new option where you can fix the time step and the total time. I wish to increase the total time, so I'm increasing this from 1 to, let's say, 5 seconds. So I now close. Now I'm going to run it back. Here you can see the progress bar. Previously it just 0.01 second, so we are not able to identify this progress bar. Now we have this progress bar, and you can find the actual time taken for simulation, and this is the progress bar and how much simulation is complete. Actually, when you compare different simulation circuits for power electronics, you can find that PSIM is the tool which has the most fastest possible simulation which happens in time, right? So this is the output. So we have some steps inside here. What you can actually see is that I used to see the output, so I just click on this, go to a specific time. The input, it is at 1 into 10 to the power minus 2, which is 100 volt. Then at the output I have, it is 1.5 into 10 to the power minus 2, which is 150 volt. As an average, you can see that from 100 I can go up to 400 volts. This completes the simulation of boost converter using PSIM software. Catch you up next with the buck converter. Thank you for listening.